So as you know, our second experiment is finding the discharge coefficient of Venturimeter. Uh, so let me just brief you with some important terms first. First is Venturimeter. It is the flow measurement device which have varying cross section. This varying cross section create pressure difference which is calculated with the help of manometer, and this pressure difference will further help us to calculate discharge from the pipeline. Okay. Second is discharge, the rate of fluid flow, which nothing but to tell us how much volume of fluid is passing through a given cross section in a period of time. Now let us move on to experiment. So this is the apparatus used in our experiment due to manometer, stopwatch, measuring tank, piezometric tubes, and measuring scale. Next slide. So here there are some more pics of ventimeter. Next. A ventimeter is a measuring or also considered as a measuring device that is usually used to measure the flow of a fluid in the pipe. A venturimeter may also used to increase the velocity of any type fluid in a pipe at particular point. Venturimeter is the mostly used device to measure the discharge through the pipe. A venturi is a converging diverging nozzle of circular cross section. The principle of venturimeter is that when a fluid flows through the venturimeter, it accelerates in the convergent section and decelerates in the divergent section, resulting in a drop in the static pressure followed by a pressure recovery in the flow direction. By measuring the difference in pressure at an axial station upstream of the convergent section and the throat, the volumetric flow rate can be estimated. Next. Now, Lokesh will tell you about the application of Venturimeter.
Hello, good afternoon, sir. Myself Lokesh now. Now I will tell you the application of ventimeter. Basically, the ventimeter is used in the calculating flow rate of fluid in a tube at a particular point, uh, or setting the flow to gasoline in the ignition system of a motor vehicle. And the field of medicine is also designed ventimeter is used to measure rate of blood flow in arteries, and this is also where the high pressure recovery is required. And it is widely used in large diameter pipes such as found in the waste treatment plants processes. And these are the basic application of the ventimeter. It is my question. I will explain. And now my groupmate Nishant will explain further about the experiment.
Now procedure is explained by Pankaj.
Hello, sir. So now I will tell the procedure part of this experiment. First, we will connect the supply pipe to venturimeter. Other end is put on the tray of hydraulic bench, switched on the pump. Another flexible pipe is used to connect the outlet. The second end of this pipe is placed on the tray of hydraulic branch. After that, we have to observe two things. First, pressure drop, and second, discharge or flow rate. After that, we will adjust the flow rate, and using the manometer provided, the difference in height is measured in the scale provided. After that, we will ensure that there is no air bubble in pipe. After that, start up the apparatus, note the readings and different flow rates. Using a manometer, ensure that there is no air in bubble. Now my friend Nishant will tell you about formula used.
No, formula used was explained by Mono.
Hello, good afternoon, sir. Myself, Mohan Prajapat. I will explain the formula using in this experiment of Venturimeter. So here we calculate our Q actual by using the formula that is B over T, where B is your our volume, which we can calculate by multiplying area with the height and theoretical discharge we can calculate by using formula Q theoretical equal to A1 A2 into under root 2GH divided by under root A1 square minus A2 square, where A1 and A2 are the areas of plate and throat of venturimeter. And after that, we'll calculate the coefficient of discharge by using the formula that is CD equal to Q actual over Q theoretical. And the further part will be explained by my teammate Nishant.
Now there are some observations. The diameter of type is 40 mm and D1 is 4 centimeter, D2 is 2.366 centimeter, A1, A2 we can calculate, and the area of collecting tank is 6750 centimeter square. The rise of water is 5 centimeter. G is 981 centimeter per second square. Everything we have taken in CGS. Now this is the observation table. First we have left limb reading and then right limb reading of manometer. And the head loss is calculated by this formula 12.6 left limb reading minus right limb reading, and this is the time to reach 5 centimeter height. And these are the readings of Q actual and Q theoretical, and the coefficient of discharge is calculated as Q actual upon Q theoretical. And the average coefficient of discharge we can find by these four readings, and this is our result. Now the graph which comes between actual discharge and head loss is this. This is somewhat straight. So this is all about the experiment.